So now that we have learned all about RNNs, LSTMs and GRUs, we are now going to look more in the code side of it. We have understood the whole theory part of it, right? So now what we are going to do is basically we are going to understand how we can implement different projects using RNNs, LSTMs and GRUs. So we are going to understand how different sequence model work. Okay, so first, before we start that, let me just remind one more time what RNN, LSTMs and GRUs are. Okay, so they are basically, if you remember, they are used for sequence based problem statements. So you might have some time series, or you might have to understand a text. See, if you think about a paragraph, right? So what is a paragraph essentially? A paragraph is basically a sequence of words, right? So they are aligned and they are assembled in such a way so that now you can understand what is happening in it, right? So that is basically your whole paragraph thing. So we are going to understand how this sequence, basically how we are going to use RNNs, LSTMs and GRUs to understand this whole sequence part of it. Okay, so what we are going to do today is, our whole project is basically sentiment analysis. Now, although you might have learned sentiment analysis using different machine learning models, we are going to do sentiment analysis using LSTMs. So this is going to be a bit different, alright. So we are going to talk about how this works. But before that, let us just quickly revise over RNNs, LSTMs and GRUs. The reason why I am focusing on this so much is because, see, people tend to forget the structures very often. If you keep remembering it again and again, it is easier for you to remember what is happening, right? So that is why what we are going to do is, we are going to understand the structure of RNN and LSTM and GRU all over again. So let us talk about RNN. First, talk about the number of inputs that you have. So you have input at time step t, input at t, and then you have a hidden state at t minus 1, right? So these two are your inputs. Okay, so you have something like this, a cell, you have your hidden state here, ht minus 1, you have your input from here, let's say xt, and then they all pass through a tan h, and then this gives you two outputs. This is the basic RNN architecture. This is like the simplest model. Okay, so here what happens is, basically you have your inputs, it goes in, it passes through a tan h, you get the output, and this output, if it is passed through a softmax itself, you get y. Otherwise here you get your next state, hidden state. Alright, so that is the whole thing about this whole structure, right? You understand this part. This is the basic RNN. So what were the problems with RNN, if you remember? So one of the problems with RNN was, it was not able to understand long sentences. So long term retainity was not there, so it could not retain long term sentences. Okay, so that was one problem. The second problem that was having with RNN was basically the problem with your exploding gradient, vanishing gradient. If you still have a problem with this, again I taught about this in the last class, and I also taught about this when I was teaching about multi-layered perceptron. So go back in the videos, revise it one more time, and then come back if you have any doubts with this. So these were the problems with RNNs. Why was this a problem, if you remember? See, here you just basically have a tan h, and inside that you have wht minus 1, xt and b. Okay, so these are the few terms, and it is just passed through a tan h function. This is more of a multiplicative statement. So if you have multiplicative values, your back propagation is going to be very high, right? So in that case, you might have these problems of exploding gradient and vanishing gradient. Hence we had the concept of LSTMs. So in LSTMs, what was happening, if you think about it, in LSTMs you had this cell, here you had the ht minus 1, your previous state, your input x, and then you had three gates. You had a forget gate, you had an input gate, and then you had an output gate, right? Then you also had a global context state. This corresponds to your long-term memory, and this hidden state was basically a short-term memory, right? Forget gate basically gives you value between 0 and 1 using a sigmoid function. So this helps you tell whether you have to forget it or you have to remember it. Input gate, basically it has two parts. It has a sigmoid function, it has a tan h function, and they get multiplied at the end. And then you have the final output one, which actually updates your global value. and then gives you HT and YT, right? So these was everything that was about LSTMs. Now the problem was LSTM was, see, LSTMs have a lot of parameters, hence the next thing that was introduced to us was basically GRU. So in GRU what they did was, instead of using two different states, it combined together to form one state. So this state was responsible for both long term and short term memory, right? So you had the GRU here, and then this was basically helpful in understanding this thing. You had a reset gate and you had an update gate. So this was everything there was about GRU. You understood this? Okay, so now what we are going to do is, we are going to understand about sentiment analysis. If you remember, when we talked about RNNs, right, I told you how different RNNs work. Okay, so we had RNNs in this form where each cell was responsible for giving an output. This was basically used in NERs. Then you had, so these were like more one-to-one architecture. Then you had many-to-one architecture. Then you had many-to-many architecture, and different things were used for different stages, right? If you don't remember, go back to the RNN video and understand this. One-to-one is the basic neural network. Many-to-one was basically used if you were giving sentiment analysis. Many-to-many, this was basically used if you are using an NER, that is a named entity recognition, or this can also be used if you are using what? If you are using an encoder-decoder kind of sequence for machine translation. We are going to talk about this in more details, obviously. But yeah, so this was basically the whole point of this. Okay, so what we are going to do is, we are going to use this many-to-one architecture. So what is many-to-one architecture? If you remember, you had these RNNs, many RNNs together. So each word will go here. Let's say I have a sentence, I am very happy, and you have to get the sentiment of this. So in the first RNN cell, it will go as I am, here you have very, and then here you have happy. So all these are connected. You have your previous hidden states going in here. It is connected like this. This is one layer, and this final one is responsible for giving me the output of the sentiment. So my sentiment, it will give me the output, what sentiment this whole sentence carry. Okay, so that is basically my whole thing about sentiment analysis, how my many-to-one architecture is going to work. So that is what we are going to understand in this particular code. Okay, so let us understand each and everything one by one. But yeah, this is the whole point of it. Now the reason why they are capable of giving outputs, we are not going to use these outputs, because you can only understand the complete sentiment of a sentence after reading the whole sentence. It is not possible to understand the sentiment without reading the whole sentence. So these outputs are not useful, hence all these, it will just give me one output. This is a many-to-one architecture. Okay, so that is what is going to be used in a sentiment analysis. Now remember these architectures, because they are used a lot. So let us come back to sentiment analysis here. So this is my code. You will be provided this whole notebook. So this is how it starts. So here we have some basic imports, right? So let us import the whole thing. You have NLTK library being imported. You have pandas which is being imported. From corpus you are going to import stop words. If you remember, what are stop words? Let us talk about stop words one more time. We have already talked about it, but let us revise back again. So when we talk about stop words, what are stop words? Stop words are basically simple words like this, the, and, am, and all these simple words that are there a lot in sentences, but they don't actually add a lot of value to it. So these words are not very important when you are understanding the whole context of the sentence, right? So that is why we import stop words, so that we can remove these words from the sentences. Then we have text blob library. Then you have sklearn pre-processing. This is, we are importing what? Label encoder. We will be talking about label encoder. You might remember label encoder already, but we will be talking about it. Then we have collections. You are importing counter. You have word cloud. If you do not see, if this gives an error and if it says word cloud is not installed, I would suggest to go here and install word cloud. So it is a simple statement, pip install word cloud. So here it will install word cloud if it is not installed. What word cloud basically does is, it gives you a very good representation. Here I'll show you. See this, it gives you an image. In that image it will show you all the words that are there in your data set, but the difference is it will show you words according to, so the sizes of these words, they will change according to how relevant it is in the entire data set. So here love has been used a lot in the data set that we are going to use. So since love has been used a lot, you can see it is bigger than other words, okay. And then Alexa is used. So if you know the data set, you will understand what I am talking about. So we are going to talk about the data set next. Then after doing word cloud, we are importing matrix, confusion matrix and accuracy score to see how it is working. We are importing sequential models. So if you remember what is sequential, if we have talked about it, so let me go back again and talk about sequential. So sequential is what, if you remember in keras.models, there is something called sequential. So it basically says when you are making the layer, when you are making the model, designing the architecture, sequential basically means all the layers are one after the other in a sequence, right? So that is what it means. So if I am using two dense layers, so one dense layer will be after the other dense layer. So that is why we use sequential, so that it can understand it is one after the other, right? Then you have a pre-processing tokenizer. So we will talk about tokenizer. You have importing pad sequences, we'll talk about this as well. Then other things other than that, you have been importing some layers. These layers will be used to what? They will be used to make your entire architecture, your model. Finally, you have a train test split from sklearn and matplotlib and numpy, okay. So this is the basic thing. Now what we will do is basically we will understand the data set, okay. So let us run this. So I have a TSV file. TSV file is basically like a CSV file. Instead of being a comma separated file, it will be a tab separated file. So let us look into that to understand how the TSV file looks like, okay. So this is our TSV file. Let us open it with a text editor to understand. So you can see all these have been separated with tabs. And this is my entire data set. So what this data set is basically, it is an Amazon Alexa data set. Here we are getting the reviews from Alexa data on different items, okay. So these are basically different items and we will be getting reviews on them from Alexa, and these are the ratings. So here what we are going to do is basically we'll be giving a sentence to it, and then we'll change these ratings into positive or negative. So if it is greater than 3, then it is a positive comment, else it is a negative comment, alright. So what we are going to do is we'll be giving our model this sentence, any review, and our model will have to predict whether this is a positive sentiment or a negative sentiment. That is our task. This is the whole data set you can see here. So now let us look into this. So I am reading a CSV file, read CSV. Here instead of, I'll just change the separation. So anytime when you are using a read CSV file, right, in read CSV file automatically the separation is a comma, okay. So because it is a CSV file, CSV means comma separated file, so it is going to read comma as your separator. But since we are using a TSV file which is a tab separated, so I am going to change the separator to \t, okay. Next what we are going to do, we are going to read the sentiments of it. So if the rating is greater than 3, we get a positive feedback. If it is less than 3, we get a negative feedback, okay. And that whole thing we will be going to apply on our data set, on our the file, the TSV file, on our database. We are going to do that, and then we are going to save it in a sentiment row, okay. So our row is basically sentiment, and we are going to save it there. And this is what basically, this is your data set, okay. So let us run this. So now that has been done, let us look into how our data looks now. See, you have ratings, different ratings. So this is rating 5, rating 4, rating 5, different ratings are there. Then you have the date variation. We are not going to use any of this. Then we are having verified reviews, love my echo, loved it, and different sentences. These are basically reviews. Our task is, given these reviews, we will have to predict the sentiment behind it. Then you have feedback. We are not interested in this row as well. The only columns that we are interested in is basically this verified reviews and the sentiment, okay. So any sentiment that is above 3 basically is a positive sentiment, else it is a negative sentiment. That is how sentiment analysis works, right? So that is what we are going to do. So our very first task, whenever we have any task that is related to text, is basically cleaning your data set. Okay, so this is a very important task, cleaning your data set. So that is what we are going to do first after reading and understanding the data set. So we read and understood the data set. Our next task is basically cleaning the data set. So that is what we are going to do here. So we have read the data set here. Now what cleaning can we do when it comes to text? If you remember, we have talked about this. I've shown you the ways in which you can clean data and how it can work. Okay, but we are going to go back and revise it again. But before that, we have to check if there are any null values or not. So you can see here in verified reviews there are no null values. That means there is no empty blank in verified reviews. All the columns, all the rows have been filled up. And this in the same way sentiment. In sentiment also all the columns have been filled up. So there is no negative sentiment or no zero sentiment. That means we have the entire data set. Our data set is not missing in that way. If it were missing, we would have to find alternative measures to change the value or so but since it is not missing, we don't have to worry about it. Next, what we are going to do is we are going to do a cleaning on our data set. So one by one we are going to complete each and every task. So let us talk about this. We have completed reading the data set. Now we are going on cleaning your data set. So how are we going to clean our data set? Let us look into that. Okay, so we have our data set. The cleaning that we need to do is in the input of it. Okay, because see, our output is pretty much either it is positive or negative, so we don't have to change any output when it is in the label format. Okay, so our labels are already there, it is clean, so we have to change our input format. So here you can see sometimes it is capital, it is small, you have exclamation marks and everything, so these things are not required. So what we are going to do is we are going to change that. So this is my function, cleaning function. Here we are doing some basic cleaning. Now when we are doing cleaning, we have to make it way more advanced, but here just for the sake of understanding, I am going to do a basic cleaning. So what are the cleaning that I am doing? The very first thing that I am doing is converting it into lower. So how am I converting it into lower? See, first what is happening is we are inputting two things here. We are inputting the data frame and we are also inputting the stop words. So why this we will understand, but we have the data frame. Once you have the data frame, what you will go is you will go through all the verified reviews. In all the verified reviews, you will go through each and every review, and for each and every review what you are going to do is basically split the reviews. So let's say my data is basically the sentence in one of the columns is basically I am very happy. So the very first thing that I am going to do is basically split it into words. So now it becomes I am very happy. Right, these are words and it is all together in a list. Okay, so that is the first thing that happened. So it split. The next thing what we are going to do is convert each and every word into lower case. So now what will happen is I am very happy. So it is now converted into lower case, right? Now once it has been converted into lowercase, we are going to join it. We are going to join it with what? We are going to join it with space. So what join does is basically join converts a list into sentence. Like in the same way when we were doing split converts a sentence into a list. Join does the opposite. Okay, it converts a list into sentences. So what we are going to do is now we are going to join it, and we are going to join it using what? If you see here, this is a space. So we are going to join each or every word using a space. So now what it will become? It will become I am very happy. So now I have this sentence. It has been joined and the first part is done. So that is, let me write it here. So this is basically so my very first task was converting to lowercase, and that has been done. The next thing that I am going to do is replace the digits and numbers. Okay, so let's suppose I have something like this. Let's suppose I have a sentence that got 3 dogs. Right, this is one sentence, one review. So here what I am going to do is basically replace this 3 with what? A blank space. So now the reason why we are doing it is, see, because we have to understand words. We do not need digits when we are understanding words. Hence we are going to convert this part. So here what we will do is, see, again we are going to first split it. Okay, no, here I'm sorry, we are not going to split it. Here what we are going to do is basically we are going to go through the string and replace every D. So D, if you remember, this is basically regex, and D basically means digits. So I'm going to replace any digit with a blank space, not even a blank space, just an empty string. So now my numbers have been removed. The next thing is basically removing the stop words. So stop words are basically small things that are not very required, so we are going to remove that as well. Okay, so here what we are going to do is we are going to go through it and we are going to split it into tokens. In the same way, now I have a list in this format, right? I am very happy. So let's suppose, and then once that has been done, we are going to join it with blank space. But before joining it, here we have a condition. So we are going to join it only if that word is not in stop words. So small words like I am, all these words are not very required because these are stop words. So in that case, let's suppose for this instance only am is not a stop word, and only am is a stop word. So I very happy is going to be there. So first it will be split in this format, it will be converted to lowercase. Then what will happen is basically you will be joining it, but you will be joining only the words that are not in the stop words. So I am happy, this becomes like that. If very was in your stop words, okay, so I don't know whether it is there or not, so we cannot rule it out, but for the sake of understanding, let us imagine that very is in the stop words. So in that case what will happen is this very will get removed and our sentence becomes I am happy. This is removing stop words. Stop words basically are essential to be removed because think about it, stop words basically what they do is they add more insignificant data to your already data set. Okay, so since we do not need these words, they do not add to the sentiment value of it, so why keep them? Just remove them, becomes easier. Next we have lemmatization. So what does lemmatization do? So we have lemmatization. If you remember, we have talked in the previous class about stemming versus lemmatization, right? So if we talk about stemming what happens, see, both have the same motive, their motive is basically to convert it into a base word. So let's say I have a word called talking. Okay, talking, talked, talks, all of these are very similar words and they mean the same thing, but then since we will be embedding it and converting it into different vectors, they will have different values, but they should all technically have the same value because they are all related to talk. So what I am going to do is, using lemmatization, I am going to convert all these words that actually have the same origin into that origin word or the base word. So stemming and lemmatization, they have the same task. The difference is basically in stemming what happens, they get converted into the base word and sometimes the base word might not make sense. Okay, so we have lemmatization so that we can understand what the base word is. Now let us talk about the different steps. First you had understanding the data set, then you had cleaning. Cleaning basically, in this case what we are doing is basically lowercase, that is converting to lowercase, removing digits, and one final other one that we are doing is basically what? Removing, yeah. So these are the two cleaning steps that we are doing. The third step was basically removing stop words. By the way, whenever you are doing any text problem statement, if you have any text problem statement or you are doing a task on text, these are some of the steps that you have to follow. Okay, so after you have removed the stop words, the next thing is basically converting them to base words. So lemmatization or stemming. So all this basically, these 3-4 steps have been done. Okay, we have read the data set, now we have converted the whole thing, and that is why here, if you remember, in our function we are actually having an input of stop words, so that this function can basically remove the words that are not required. Okay, so once that has been done, what we are going to do is we are going to use this function and we are going to change our data set, and finally what it returns after all the cleaning, it returns the final data frame. Okay, so once that has been done, now our data is clean. Let us look into how our data set looks now. this is our final data set. These will be our inputs, this will be our output. Okay, so this has been one form of cleaning. We have cleaned the input form. Here if you see, how was it? Love my echo, my is a stop word, so that was removed. Love, echo, and L and E have become small letters, right? In the same way you have love it, and then you have all these in small letters, right? The other thing that you have to do is, see, I have not included here because accuracy is not one of my whole point of understanding. My whole point is basically to make you understand. You can do basically is remove the punctuations as well. Okay, so if you remove the punctuation, it becomes way more easier to understand the stuff. But for now, let us keep it there and let us see how our model performs. Then finally what we are going to do is, once we have all these reviews, what we are going to do is we are going to make a word cloud out of it. Okay, so what we are doing is basically we are going through each and every review in the whole data frame. Okay, once we have gone through the reviews, we are going to split it into words. Now they have been split into words. We have different words. We make actually an entire sentence, and this sentence contains all the different reviews from all the entire verified reviews column in the database. Okay, so once that has been done, what we are going to do is basically we are going to generate a cloud and show it. That is it, basic. This is very simple. This is basically a form of analysis. You want it, you can do it. You don't want it, you cannot, you might not do it. Okay, this part is totally optional. This just basically makes it easier for you to understand what is in the data set. Okay, so once that has been done, see, all this part has been done. This part was basically here, this part was basically cleaning your input. We also need to clean our labels. How do we need to do that? See, if you remember when I was talking about it, I always mentioned that your model understands only numbers. It is not able to understand words. So you need to change everything into numbers. Till now our input is in the form of words, so we have to change that. In the same way, our sentiment is also in the form of words. So this sentiment is basically our label, so we need to change even our labels into different numbers. So that is what we are going to do here. We are going to call label encoder. If you remember label encoder, what is label encoder? Label encoder was there in scikit-learn. You might have learnt about it. If not, we are going to talk about it again. Not scikit-learn, I'm sorry, sklearn. So in label encoder, what happens is your different labels get converted. They are given some numbers and it gets converted into those. Since we have only two labels, so in that case what will happen is our labels will become 1 and 0 in that format. Let us look into it so you'll be able to understand. So we are calling a label encoder and then we are putting it into the fit transform part so that it gets converted. Okay, now that we have done it, let us look into how the data frame now looks like. Now you can see the sentiments have been converted into 1 and 0. So one thing that you can see is if you have positive sentiment, it has become 1. So let us look into negative sentiments if we have any. So you can see this is a negative sentiment, it has become 0. So my negative sentiment is now a 0, my positive sentiment is now a 1. So if your model gives you outputs in zeros and ones, you have to understand 0 stands for negative and 1 stands for positive. Next what we are going to do is, see, these steps are over. Our next task is basically your tokenization. I have to change the input format into different numbers. So my label has been changed into numbers. The numbers are 0 and 1. My next thing is basically changing my input, that is the reviews, into different numbers. So that is what we are going to do. The very first step for doing that is basically doing the tokenization. So what happens in tokenization? So we have tokenizer. So what tokenizer are we using? If you remember, we talked that Spacey, text blob, all these also have tokenizers, NLTK and stuff. What we are going to use is we are going to use the pre-inbuilt Keras tokenizer. Okay, so it is easier because it converts directly into the form in which we want for our output. Okay, so that is why we are using the Keras text tokenizer. So this tokenizer, what it will do is basically we are calling the tokenizer, we are giving it number of words. So it will use what? 500 words. So 500 most common words will be converted into tokens. We are not using all words because there are some words that are like very unique and that will just add or increase the length of a dictionary, but will not actually be required. So we are going to use only 500 topmost words, okay, and we are going to split it in the form of this blank space. So we will have words and these words will be split in the form of blank spaces. Alright, so next we are doing fit on text, and this fit on text will be basically inputting what? So it will be having a data frame, verified reviews, so the column of a data frame and the values of it. Okay, so that is done. Then once that has been done, so if we look into it one by one, so now our tokenizer has been trained on those text. The next thing that we are going to do is basically convert the text to sequence. Okay, so let me first, for instance, remove the padding. Okay, so I am commenting this, we are going to look into it afterwards. So you can see here what has happened is basically you have all your text, so depending upon the number of text that you have, it gets converted. Okay, so in this format it has converted each and every word into some particular number, but it does not end in this manner. What happens is, see, in tokenization what happens is you have words and it will take top 500 words because you have used 500. It will take top 500 words. Let me clean this. So top 500 words will be taken, and after what it will do is basically for each of these 500 words it will assign a number using text to sequences. Okay, so using text to sequences it has assigned a number to each of these 500 words. So that is why when you are doing this you are getting these values. Here you can see my love and echo have been assigned number 1 and 2. My love it has been assigned 5. There is no other word, maybe because it does not include in the top 500 words. So in that way you have all this converted. Now you might be able to see one problem instantly when you look at it. See, the problem is, if you think about it, when we are talking about RNNs like RNNs or LSTMs or any such sequence models, when we talk about it, one thing is we always have the same number of cells in the particular layer. So if I am using 5 cells in this layer, so for my next text again it should be 5 cells. So this should not change because in each layer the number of cells is going to be constant. You cannot keep changing the number of cells because your model has to train on that many text, so it has to understand that. So you have to keep this constant. But the problem with our text is, not our, but let's say any text. I have 2 different sentences. I am very happy, I am happy. Okay, these are 2 different texts. Okay, this is after you have done all the cleaning and everything. These are the 2 texts that you are getting. This is 4 words. So how many cells will it require? It will require 4 cells if you think about it. So you will have one which will go in with I, then it will have one where am, then it will have very, then it will have a happy, right? So it will require what? 4 cells. Now think about this sentence, I am happy. So after 4 cells this will give you an output, so we will not be requiring the 5th cell. Now let us take the second example, I am happy. So I am happy, you got it here. But what are you going to do with this cell? So what we do is, to solve this problem, since the text, the sentences are of different length, the main thing that we can do is basically pad it. So what happens in padding is basically after doing I am happy, I add an extra space behind it. Okay, so I am happy and then it will pass a space here and it will give me the output. So in that case, depending on the size, any size of sentence, let's say I am, this is a sentence. So even in this sentence what will happen is it will pad 2 different spaces. So it will pass I here, am here, and then 2 spaces here and here and give you one output. So what this does is pad sequences. Pad sequences basically converts all the sentences to the same length by padding it. So by doing that what will happen is your number of RNN cells can remain constant, so you will be able to train the model. Okay, because in one layer of RNN you have to predefine the number of cells that you are going to use. Okay, so if you don't do that it will not work. So that is why pad sequences is important. So let us pad it. So now you can see it has been padded. Now all the sentences are of the same length. So that is important. So remember, whenever you are doing this you have to pad it. So let us go back to the steps. So we converted tokenization has been done. The next thing that we are going to do is basically padding text. This is an important step. If you don't pad it, you have to trim it or other things, but padding is important. So in padding, what happens is there are two different types of padding at the back, padding in front, whatever. Okay, here we are doing padding at the back. So the last words, the words that are there, they will be at the end, and before that it will be padded with a lot of zeros, right? So that is how we have now finally our input and output both have been converted into numbers. That is a big thing. So we have the numbers for both our input and output. The next thing that we are going to do is basically define the model. So you need to understand, see, we have completed different parts that were required, right? So we completed the different parts, that is understanding our text. These are all pre-processing parts, by the way. We haven't come to the model part yet, right? So these are parts that you have to do when you are training for any text part. So these are kind of important steps when you are doing any task that is related to text. Okay, so be it analysis, sentiment analysis, or be it named entity recognition or anything, you always have to remember these steps are important. So now what we are going to do is we are going to build a model. So our model, it starts with sequential. You have to define what kind of model you are going to use. We are using a sequential model. If you remember, sequential model is what? Sequential model again means that all the layers are in the form of a sequence. Then in the sequential model, what we will be adding? We will be adding an embedding layer. So what is embedding? So what is embedding? Let's talk about embedding. We have talked about it, I suppose. So if we have embedding, what does this mean? So embedding basically means you have different, see, our words have been represented, our words have been converted into numbers, right? But the problem is, even though they are numbers, they are just random numbers. So what we need to do is we need to convert these random numbers into some form of a vector. We have talked about word to vec, right? So that is one form of embedding, if you remember. So we need to convert that into different vectors, so that now these vectors are able to understand different relation of different words with each other, relation of words with sentiment, and so on, right? So that is one step that you need to do. This embedding layer has to be there. So once you have the embedding, so embedding 500 means we'll have 500 dimensions. Okay, so that is one thing. Then you have a dropout layer. So this spatial dropout 1D is the same as a dropout layer. What this basically does is we'll have 40% dropout in every different running epoch. Okay, so that is one thing. If you remember, dropout is basically what it gives you. So dropout basically helps you to remove the overfitting. Then you have one LSTM layer. So LSTM basically, here this 176, I know you might be thinking what this 176 is. Here let me give you an example what this stands for. So this 176 basically means the number of see, when you start you have 500, right? This 176, what it does is basically 176 basically tells you the number of features that you will be using. If you remember, when we talked about LSTMs and RNNs, I mentioned that the inputs can be a bit tricky to understand. So you have the input in the beginning, you have batch size, then you have the number of time steps, and then finally you have the number of features. So 176 basically means our output should have 176 features. So every word will now have 176 features in the output. Okay, so that is what this 176 means. Here also you have a dropout of 0.2% and recurrent dropout of 0.2%. So recurrent dropout basically means randomly different cells will be dropped out. So you have the cells in this manner, right? So randomly 20% of the cells will get removed. So in this manner. Once that has been done, we add a dense model to it. So this dense model has an activation of a softmax function, because our final thing, if you remember, we have a many to one architecture, right? So you have different RNN cells connected, and then the final one is basically giving you my sentiment. Since my sentiment is either positive or negative, two outputs, I could have used even a sigmoid function, but I am using a softmax function here. So this softmax will finally give me the output, whether it is a positive or a negative function, depending between what the value comes in. Okay, so these RNNs are connected in themselves. So that is one thing. The final is basically compiling. So here the model gets compiled. you have see, that is why you have dense 2. That means it gives you 2 outputs, for one positive and one negative. Okay, now the loss we will be using is categorical cross entropy. If you remember, we have talked about the different losses. If not, I would suggest to go back on the videos and understand. We will be using Adam optimizer. We have talked about this as well. Adam is used a lot, that is why it is no big thing that we are using Adam as an optimizer. And our metric will be accuracy, how accurate my model is giving whether this is a positive or a negative sentence. Then finally you have model.summary. So what we are going to do is basically see the summary of it. So you can see here the most number of trainable parameters are in our LSTMs, right? So this is basically the one where you have the most number of trainable parameters. In LSTMs, you do not have to input the size of the array. Okay, you do not have to input the size of X or the number of features or anything that you are using. You have to just input the number of output features that you want. Okay, so here you see you have an output feature of 120. I want to increase it to 176. That is what this whole thing is. Next, what we are doing is, once that has been done, we are going to get what? We are going to get X and Y values, and we will split them into X test, Y test, X train and Y train. Okay, that has been done. So now what we are going to do is, basically once you have the training and testing, you can see 30% will be used for testing and the rest will go for training. Okay, so we will be using the sentiments and we will be splitting it into the values that is required. You have an X and Y value. X and Y value, how did you get? So you have the X values already, and in the Y value what they did was basically use the sentiments and then split it. So this is the basic. This is not a bigger deal. You might have learned all of this when you were doing machine learning, so we are not going to discuss that. This is using sklearn. You remember all of that. Then we will be converting what into arrays. So now we have X test, X train, Y test and Y train. So they have been converted into NumPy arrays. So why arrays? See, whenever you are training a model, you need to convert it into a particular form so that your model is able to understand what is happening. Okay, so to do that, you cannot just input data frames as they are. You need to convert them into arrays. Once they have been converted into arrays, now what you can do is basically train them. You can fit them in and you can train them. If you remember X, what was X? X was basically this array. Okay, so it is already converted into an array, but doing an X test Y test split basically changes the whole format, so you need to convert it back into an array. Now what we are going to do is, I am going to remove the number of epochs from 5 to 1 because it takes a lot of time. You can see here I have trained it already. It takes about 40 seconds to complete one epoch, so I am going to just remove it and keep it to one epoch so that you can see it later when you are training. Obviously change it depending upon how you want to train it. Okay, so we are doing a model.fit. We will be fitting what? X train and Y train, and what we are going to do is basically we are going to use X test and Y test for our testing purpose. I am going to use one epoch. My batch size is 32. That means 32 different sentences will be fed together at one particular time. Okay, so 32 will be fed if my total size is, let's say I have 64 sentences total, and my one batch size is 32. So in that case what will happen? I will have two different batches. My first batch will be 32, the next batch will again be a 32, and then I will complete one epoch. If you remember, this is how it works, right? So now verbose is 1 basically means it will show you all the outputs. If you keep verbose as auto, in that case what will happen? It will show you no output of how the training is going. You can keep the verbose as 0 as 1 as well. In 0 also it will not show you any output on how it is working because 0 is your default value. So what we are doing is we are going to keep this as 1. Okay, now let us run this. So you can see it takes some time to load the whole thing. The data set is large, so it might take some time, hence I kept the number of epochs to 1. Okay, batch size is 32, like you can see. So it will start the whole training. It takes some time. The first epoch anyway takes a lot of time, so you need to bear with me there, and that is it. So this will be going on. I'll show you once the results are done. So you can see here it has been started. You can see so it has like what? It has 69 batches. So that means if you think about the data set size, it is more or less like 69 into 32. So this is my data set size, actual data set size. So this is what it will be training. You can see the loss is decreasing, the accuracy is increasing. You can see the estimated time to completion is 27 seconds, 26 seconds. It is just decreasing one by one. So this basically concludes what we have or what we talked about when we were talking about sentiment analysis using LSTM. Okay, so we used LSTM. In LSTM, always remember this embedding has to be there. You can or cannot add dropout. It is up to you. Since our data set is not that big, that is why I added a dropout to it. this LSTM. Here your input should be on the number of output features that you want. Our LSTM output will be none, 176. None basically mentions what is your size. Okay, so none basically here, if you remember, we have talked about that also. None basically mentions what your batch size is, right? So here, since we have not given a batch size, it shows you none. So you can see my fit has been done. So I have completed my training. The loss is high, 0.46, but that is because I have just run it for one epoch. My accuracy is 84%. We can work with that for now, then we will see how it works. Then what we are going to do is we are going to evaluate the model on our X test, Y test. Now what you can do is you can save your model as well. You can see it gave you an 85% accuracy. So it is not yet totally sure. It will take more epochs to understand the whole data set, but if you are running on your data set, right, if you are running this notebook, make sure to change the number of epochs depending upon how well you want. Okay, and one more thing that you can do is you can plot your history, or you can plot the graphs that you get. Now I am not going to do that. The reason why is keep this as a task so that after doing this you can add the plots as well. So this is everything that has to do with sentiment analysis. Okay, so we have completed the whole topic. One more quick revision. What happens basically is when you have text, you need to understand the data set. Number one, you need to clean the data set. Here we have just done lowercase cleaning and removing digits. You can add removing punctuations and other things. Okay, depending upon what your data set is, how clean or how messy the data set is. In real life, the data set is going to be really messy. Okay, so you need to be very careful of what you are doing. Then you can remove the stop words. Obviously this is an important step. Then you have lemmatization and stemming. These basically what they do is they convert a word into their original word. Okay, so different words might have different meanings, so it will convert it. You can add different spell checkers to it. You can add different libraries. What they do is basically convert your lingo, which is the present lingo, like using K or into actual words that can be understood by a model. Then after that what you can do is basically you can go for tokenization, which is followed by padding. Once this has been done, you can add an embedding to it. So what all of this will do is basically convert your words into different vectors, right? And these vectors will be able to understand how one word is related to the other word, how one word is related to the sentiment, how a sentence is related to the sentiment, and so on. Okay, so that is one thing. And you have to make the changes in the Y column as well, in the labels column, so that it is able to understand what is being used, what is not being used. So that is it. I hope you understand the video. Take your time. You will have this notebook given to you as well. If you do not understand, take your time. That's it. And in the next class we will be doing some other projects. Now that we have completed everything that was there in theory, we are going to be doing more projects, and I hope you enjoyed the video and keep learning.